Hi, I'm George Herbig, your WeatherWise tour guide, if you will. And on this WeatherWise tutorial video, we're going to talk about the composite section at the top bar. Now, this is going to be a really useful tool for talking about history of storms, other different dynamics that we can look at as well. But instead of yapping about it, let's go ahead and break down what everything means. Now, let's head to the WeatherWise app for the first time on our browser on the PC. Now, you can type this into your mobile browser as well, or of course, download the apps. But of course, let's go ahead and type this in web.weatherwise.app. So we've got our WeatherWise radar open, and once again, I want to remind everyone that everything that we talk about here on the browser that we're actually using can be found on your WeatherWise mobile app as well. It might look slightly different, but I promise it is there with a little bit of looking, and most things are pretty easy to find on WeatherWise. So I just wanted to put that little disclaimer out there. So again, what we're talking about today is the composite. If we look up here at the toolbar, we have radar, composite, satellite, and models. Now, a lot of people get confused by radar and composite. So one big key difference here is when you click on radar, you have all these blue pills here that show you all the different regional radar sites. These are really great to use for small scale events or small scale radar looking, if you will. So for example, if I wanted to zoom in on a more specific scale, we have our radar here, and it only goes out to this distance really. But if I wanted to look at, let's say, a national look at things, I can click on composite up here at the toolbar, and now we pulled up the entire national radar here of the continental United States. Now, there are different zones, we'll talk about that, but this is a good general overall look here at what you're expecting to see. And there's also some more cool tools down here in the radar drawer that we can take advantage of and look at, and we'll talk about what the most useful tools are down here, or two of the more popular tools in each section, just to kind of give you an overall general feel for what these are, what they mean, and how you can take advantage of them. But before we get into that, let's go ahead and look at the regions that are available on the MRMS composite radar offered by WeatherWise. And again, just a reminder, this is free. There are a couple of plus or pro options down here. I'll scroll down and show you. And I'll switch over to my paid subscription later on in the video and show you how those are pretty useful as well. Okay, so the zones look like this. We have CONUS, which obviously means the continental United States. So this view looks at everything that's happening anywhere in the continental United States. Alaska is focused on the Alaska area, as we can see there if I scroll up. Hawaii is obviously focused on the Hawaii area, Caribbean, and then Guam. So pretty self-explanatory there on the zones. They cover different areas. Some are smaller. The continental United States is what most of you are going to use, so that's what we're going to use on this video. By the way, real quick note, down here we do have another tropical system developing out here in the Atlantic. We did make a video on that a few weeks ago. Make sure you go check the WeatherWise YouTube if you want to learn more on how to track tropical systems. Now that we have our zones identified, I'm going to scroll in a little bit here. Actually, close our radar drawer for a second. Scroll into this big blob of mess that we have in the central United States. So now that we have our overview complete, let's talk a little bit more about what each one of these means. So going back up to the top here, reflectivity is obviously going to be the rate of precipitation that is falling. And of course, we can reference the key at the top here, or we can actually hit this inspector tool, kind of looks like a bullseye, pull that on our screen here, and we can see the precipitation rate. Now, obviously, a lot of us know what this is, but I do want to explain what the dBz means. dBz, or decibels of Z, the higher this number is, the harder the rainfall or precipitation is falling, whether you're dealing with snow, ice, or rain, or whatever else might be falling out of the sky. So if we scroll in real close here, we'll see that the lighter greens are lighter dBzs. The heavier yellows are your higher dBzs. So some moderate rainfall is occurring, for example, around Norris. Let's go ahead and reset that and talk about what maybe the different options mean under reflectivity. So reflectivity low and reflectivity high, reflectivity super here, your three top options. Now, most times we won't ever really use reflectivity super. This is more reserved for aircraft carriers and aircraft controllers to see kind of how the skies are looking where aircraft is traveling, to keep you a little bit more safe. Reflectivity high is stuff that is occurring anything above 24,000 feet to about 60,000 feet. This is where most of our storms take place, the top edges of them, and we'll talk about that with echo beams. Reflectivity low, or 0 to 24K foot, is actually the stuff that is happening more closer to the ground. So you're obviously almost always going to see heavier rainfall returns on to this height. Most folks will just leave this at regular reflectivity. Now, scrolling down a little bit, we have echo top. Echo top is the maximum altitude at which the radar detects precipitation above a certain threshold. Now, this also decreases as you go higher simply because most storms are closer to the ground. This tool is pretty useful for understanding how high up the precipitation is starting. So again, if we look at 18 dBz, we have a nice return there because that's closer to the ground. As we go up into the atmosphere here, we'll see that that return begins to get slower and lighter. And then as we go to 50 dBz, we'll see we're not really seeing much returning. So we know that the height of this storm is likely somewhere around 30 dBz because this is where we're getting returned at a decent rate as we're going up into the atmosphere. So that's how echo top works. Scrolling down a little bit down here to probability of severe hail. Now this one is a really useful, very, very useful tool. Now, of course, on the morning of making this video, there's really no hail to talk about, but let's go ahead and break this down for you. So the probability of severe hail and the severe hail index go hand in hand. MRMS tries to project the probability of severe hail by reading the number of lightning flashes and immediate instability of the atmosphere and combining that data with the MESH system. MESH stands for Maximum Estimated Size Hail. All that directly feeds into the prob hail model, which then spits out its best guess at the likelihood of hail in a short-term period based on all that data. So again, that's a lot to take in. There's a lot of different models and factors that go into the probability of severe hail and severe hail index. But of course, the easiest way to read this is the brighter that you see on those color returns from those zones when you click on them, obviously the likelihood of hail increases. The more dull the colors or the absence of colors that you see when you hit those zones, obviously it means the absence or unlikelihood of hail actually being able to be produced. So of course, when we're making this video, there's always something. We don't have any hail that's actually on the radar right now to show you. So that's why you see my pretty face at the moment. But let's move on to a different tab. So as pretty face George alluded to, let's go ahead and move on to a different tab, vertically integrated liquid. Now, this is going to light up really vibrant for us because there is some heavier rainfalls occurring in South Dakota, Nebraska, Kansas right now, and Wyoming as well. But what is vertically integrated liquid, or VIL for short? It is a derived product that estimates the total liquid in a column of a storm. High VIL rates indicate a large concentration of water or large precipitation particles like hail. This product signals a potential for heavy rain, large hail, or even a strong downdraft. Now that we have the explanation, let's go ahead and look at the different swaths and different tools that we have here in the radar drawer under vertically integrated liquid. So we have vertically integrated liquid here up first up. Hitting that inspector tool, we'll see that the South Dakota area obviously lights up pretty well. We'll also see we have some higher tracks here. Let's go ahead and head up toward Linton, North Dakota, where we can see that those are really, really vibrant. We'll pull all this together in a second. Vertically integrated liquid swath over the 120 minutes is exactly what it sounds like. It's the last 120 minutes of the highest vertical integrated liquids. And you'll see that being able to be displayed on the WeatherWise radar here. And you'll see that over the last 120 minutes, we have areas that are very, very, very vibrant as we go and scroll through the map here. And again, this is trying to show us swaths or tracks of the higher VIL swaths. And then, of course, vertically integrated liquid swath over 1,440 minutes is like the 120-minute one, except for longer. So that's how VIL works. Let's go ahead and move on to rotation track. Rotation track intensity on the MRMS system is a product that plots the maximum observed cyclonic shear within a storm over a specific period. It provides history of the intensity and path of a storm circulation, which can often be associated with mesocyclones, tornadoes, or damaging winds. You can view this at different layers of the atmosphere. For example, 0 to 2 km, as you see we have highlighted here, is 0 to 2 kilometers above the ground level, and 3 to 6 km is 3 to 6 kilometers above ground level. Why does the height of rotation matter? Well, oftentimes the height of rotation is super important, right? If we have rotation that's closer to the surface, that usually indicates that something a bit more tornadic or wind-based. If we have something that's a little bit more above the ground, like 3 to 6 kilometers, that usually indicates more of a hail-based storm or heavier rainfall, or wind can be associated with that as well. So where exactly that rotation is happening in the atmosphere or at the surface is super important to determining what type of storm we might be looking at. So let's go ahead and highlight rotation tracks at 0 to 2 kilometers above ground level that are instant. We obviously see that there are really none of those occurring here. We have some small speckles, if you will, nothing really brightening up there. Now, what is to happen if we put that on the 3 to 6 kilometers instant? We see there's a bit more happening here. So we know that these storms, like for example, if we scroll really far into Kansas here toward Inman and Medora, hit our inspector tool, we can see that there's actually a bit of a swath here in that area. That indicates that this storm might be producing some small hail that might be melting into heavier raindrops, because again, it isn't very bright, it isn't very vibrant. If we look up here toward the key, click on that key and make that key bigger for us there. Again, we can see exactly how that key works. Clicking off of that to make it a little bit smaller there. Again, we don't see anything really vibrant, very bright happening, so not likely any real hail occurring with this, but does indicate maybe some heavier raindrops are occurring. So we know that there's really no rotation tracks happening that are instant, so we're going to skip the 0 to 2 kilometer one and stick with the one that's 3 to 6 kilometers. Let's look over the last hour. We can see that same area has seen a track of higher rotation in that 3 to 6 kilometer range from Hutchinson to Inman. So this storm has a history of producing that. You can actually use this to determine where maybe the tougher part of the storm is. So that's really how rotation tracks work. Again, not a really great example to use this morning for you, but if we get one in the near future, I will make a short on this so that way you can kind of connect the two together. So now that we have rotation tracks, vertically integrated liquid, hail index, echo tops, and reflectivity covered, let's move on to Flash QPE-CREST. Now this one is a really cool tool, and I personally use it a lot, especially earlier in the year where we had tons and tons and tons of historic rainfalls. But what is Flash QPE? Flash QPE is used to help forecasters assess a flash flood threat through the Quantitative Precipitation Estimate, or QPE for short, and the Coupled Routing and Excess Storage, or CREST for short. QPE is the process of estimating the amount of precip from radar data, and CREST is a hydrologic model. Wow, that's a lot of fancy words that George struggles to pronounce. But one of the more useful tools in this section is the soil saturation level. So we're going to click on that real quickly. Let's zoom out and where we can actually see stuff a little bit. And you'll notice that the higher saturation levels right now in the ground are highlighting over the areas that have seen heavier rainfalls this morning. Actually, toward Nebraska, if we use our inspector tool and scrolling real tightly here, we'll see that they actually have a 78% soil saturation level. Now, one of the key markers to follow along with here is that if soil becomes 100% saturated or greater, the water can no longer seep into the soil's pores and then begins to flow over, creating standing water above the ground and, of course, leading to the risk for flash flooding. So even though that this is brightened up here at 78%, there's really not a massive concern for flash flooding in this area at the moment because, again, we're not at that 100% or greater threshold. Now, of course, if there's more forecasted rainfall over the next 3 to 4 hours or so on and so forth, forecasters can use that coupled with this tool to try and forecast when that soil saturation level might increase, thus needing a flash flood warning. Now, you'll see we actually do have some flash flood warnings if I zoom out here. Let's go down here to McCook and see what we have going on down here. And for that, I'm actually going to use the Flash QPE to FFG ratio. Flash QPE to FFG ratio is the ratio of the current precipitation estimate to the flash flood guidance. It helps forecasters by showing how much precip has fallen compared to the amount needed to cause a flash flood, with higher ratios like above 100% indicating a higher risk of flash flooding. So we'll click that on. I'm going to put this into motion here. We don't really see a whole lot happening there, but let's go to ratio max, where we do actually see some deeper colors showing up in these areas. And you can see over the last 6 hours, we'll see those same areas are there as well, which likely prompted a flash flood warning quite some time ago. Now, if you go up here towards South Dakota, where we actually have a really vibrant return, we'll see a flash flood warning is present for that area. And you'll see that this is well over 100%, 3.0, 3.1, going more toward the 300% marker if you convert that. And of course, all around it. So this flash flood warning is very dangerous. But going back to our radar drawer here, you'll see that there are so many options for Flash QPE and Flash QPE to FFG ratio. Play around with these a little bit more, do a little bit of Google searching, and see exactly which one of those you might want to look at a little bit more. Feel free to leave some comments below the video. Let me know what you might want to learn more information on in that drawer. We'll make some short videos for you kind of explain a little bit more here, but in this tutorial video, I like to focus on the two most important ones, which again, flash QPE-CREST soil saturation, and again, flash QPE to FFG ratio over any of those time periods or max. Now, finally, in this radar drawer, QPE estimates work in different time intervals, as you can see here. For example, if I select QPE radar only 1 hour, that's going to display what the radar believes has fallen in the last 60 minutes. So you can see actually in the last 60 minutes, not a whole lot has fallen in that area particularly. But if we scroll out here, we can go up to, again, toward North Dakota and South Dakota border here. And we'll see that we actually have some higher returns here of 30 millimeters, 40 millimeters, so on and so forth. So again, given all the tools that we've learned, let's go ahead and take a look back at this area and see if it might need a flash flood warning in the future. So let's go ahead and use our flash flood QPE to flash flood guidance ratio 1 hour. We actually see that that is lit up pretty well there. Using our inspector tool, it's about a 0.8 to 1.2. Flash QPE-CREST soil saturation. It's not nearly as lit up in that area. Again, because it probably just got there, but we can see where it came from, which is actually right back here, and it did get closer to 70%. Let's see how our vertically integrated liquid looks there. Is it very bright and vibrant? It is. So again, this indicates maybe some heavier rainfalls with some bigger raindrops is occurring there. And then again, if we go back to look at our reflectivity, you'll see that it's past that area, and we have lighter rains behind it. So all in all, it's very close to probably needing a flash flood warning, but since the heavier rains have moved out and lighter rains are behind, and the soil saturation level is not quite there, we know that a flash flood warning is likely not needed in that area. Now, if there were more moderate rains behind it, since we've seen the track of this one and what it's produced, we might need a flash flood warning in that Linton area toward Napoleon, but they could probably get away without it. Let's go ahead and reset our map here. And with doing that, I actually want to switch over to my subscription that I have purchased for WeatherWise, and I want to show you some of the more cool tools that are available to Pro and Plus users. So again, just to point out here, everything that we've shown you up to this point has been free. And even some of the things I'm going to show you on my personal subscription here is going to be free as well. But if you want your radar to look a little bit cleaner and a little bit more precise, I'm going to show you some tricks real quick on how to do that. So let's go ahead and click on Composite up here and get us back on the MRMS radar. And again, it might look a little bit different than yours. I have my colors set up a different way, my map background set up a different way, but it's going to work the exact same way. If you ever want a video in the future on how I got mine to look the way that it does, again, just leave a comment down below, and we'll make sure we do a quick short on that. Let's go ahead and go back down to our radar drawer here now that we've clicked on Composite, and scroll down to the bottom. You actually see that I have some settings set up already, but I want to show you how we got there. So starting from the bottom, we'll work our way up here. Reflectivity gate filter is a really useful tool. I don't like to see all the scatter on the radar that's probably not touching the ground anyway, and it just makes a radar look a lot more clustered. Reflectivity gate filter is a gate that filters out the scatter that might not be touching the ground, but be careful. If you go too high on this, you're going to cut out some of the radar. So, for example, if I put this all the way up to, let's say, 2830, you'll see we actually received a warning here. We recommend a minimum of 10 dBz. So what I put mine at is about an 8. Again, it gives me a clear look at what I'm looking at here, cleans up some of that scatter, again, compared to before, but doesn't take away from the radar or its actual real image at all. Going up here to opacity, you can make the radar a bit more transparent if it's a little bit too bright for you. Now, I wouldn't recommend really doing that too much, because again, you can lose some of the actual picture there. Smoothing is another real cool tool. So if you don't want your radar to look jagged like that, you can actually smooth it all the way up and make it look really nice and pretty. Now again, I leave mine at more of a happy medium because I don't want to lose too much of the actual real radar image. Now, you won't really lose a whole lot. It just makes it look real smooth. I don't like mine to look too smooth, if you will, so I leave mine probably at about 3 clicks. Again, you can play with that and find what you like. Playback speed, of course, is something that's very subjective. It's whatever you want to do there. But you can turn up or turn down the speed at which you hit that play button. So, for example, if I put it on really fast and I hit that play button, it's going to scroll through from 11:18 a.m. to 11:46 a.m. really, really quickly. If I put it on slow, it's going to go real slow. Now, again, this is very subjective. It's whatever you want to do. I usually leave mine somewhere toward the middle. where I get a nice happy medium. But let's say I wanted more frames. Now again, this is something that is Pro or Plus. To get more of these frames here, you can get up to 15 for free, up to 50 in Plus, and up to 100 in Pro. More frames means the more further I can go back. So let's set this on 100 frames and put this into motion here. And you can see I actually went all the way back to 830 there. Now I can scroll this through with the handlebar here, or I can hit play and let this play through on its own. And that, of course, gives us a nice history of the storm. Now, we did go over a lot in this video, and there are some things we kind of skipped over or just glanced over. So, again, leave some comments down in the bottom if you want to see some more of those settings in a more specific variety. But again, for tutorial videos, I like to touch on the two most important ones or the more useful ones that I use when forecasting things. But of course, WeatherWise has so much to offer. We could be sitting here all day talking to you about everything that WeatherWise has for free and for Plus users as well as Pro users. I'm George Herbig. I've been your WeatherWise tour guide here, and I hope you enjoyed this one. Until next time, stay safe, friends.